name's Stacy Halsey. I worked in Dr. Nanny's lab this summer, and I'm going to talk about building a low-cost fluorescence photobox for use in analysis of microplastics. So I'm not actually going to do the project because it would take too long, and this is just part of the curriculum. This is just kind of the audience, the 7th, you could probably put 8th graders and then the high school students in there. To kind of talk about the engineering process, the same as what Chris had mentioned with his standards, and then ecosystem and human impact. The objective is to create a functional, low-cost fluorescence photo box that will be used in future lessons, just because this is part of a whole curriculum. So this is kind of the outline of it. The engage is small group discussion about plastics in everyday use. That would take about 10 minutes, 30 minutes to explore a couple videos and then have small group discussions. To explain, the students will create the fluorescence photo box to use in exploring fluorescent microplastics. That'll take 30 minutes. And there's a paper that would actually go with that so that they can kind of discuss what they think would be best. And then to elaborate, they'll test the box and try different filters to see what works best and figure out ways to improve the design. And then finally, the evaluation, they will demonstrate that the photo box actually works. Okay, so here's the engage. There's a game that I have for them to play. I have never, and the game is actually to think about plastics that you may not have used in your everyday life. Okay, so they explain students will make a low-cost fluorescence photo box to use later in later assignments. And then we would dye some plastics with red Nile. So the material is kind of basic. There is a small cardboard box, black construction paper, craft sticks, see-through page dividers, multiple colors, black light, glue, camera. On your smartphone, you'd also need scissors, just some basic items. And then the method's kind of outlined, and I'm going to go through that. And you can see down here, this is the page dividers that I'm talking about, just to make sure everybody knows what those are. So you'd line the cardboard box with black construction paper. For mine, I actually used the black box, so I did not line it because I was trying to not spend a ton of time on it. And then you want to make sure that there is no light that can enter into the box. Okay, so we started out by cutting the small hole, and you can see that the small hole, the flashlight fits in, so you want to make sure that it's still airtight. Probably use some electrical tape to kind of make sure that none of the lights can get through. And then you'll cut a small hole in the middle of the box, and you can see measuring the box to kind of try to find the middle of the box and make sure that everything's right there, so that when you use your center view center, then you're able to see that in there. Okay, and then to create a kind of a guide to hold your filter in place, I used craft sticks. Glued the craft sticks on top of the box so that the filter can slide in and out. Okay, so this is again the page dividers, and you cut those into small strips. You'll want to measure how much space you have between the craft sticks that you've glued on top. I think mine were about 2 inches apart, and the craft sticks were about 4.5 inches long, so I made mine 6 inches by 1 3/4. And again, that's going to be up to however you glue your craft sticks on top of the box. And then you'll be able to insert the page divider between the craft sticks to create the emission filter. And then go ahead and put the box together. So this is just the elaborate, so this talks about what we talked about a few minutes ago. The evaluate, this is actually a picture that I took with my smartphone. I think I used the red filter and had some fluorescent paint in the middle of the box on a slide, and then it lit up. Future ones, I would actually like to see how small we could get and be able to see in this box, and then trying to look at how to change like different light sources and stuff like that. So references, I found a cool article that had a bunch of different information about how they made a low-cost fluorescent box. I think I actually beat them because mine was less than $10. Theirs was a little more expensive. And then it also talked about using Nile Red, which is something we've been doing in the lab, and a few other things on straining and collecting, extracting microplastics from the soil. And then acknowledgements, everybody that's been awesome in Dr. Nanny's lab, OU, East Central, USGS, and then the National Science Foundation. Any questions? I know that was really quick.